Have you ever wondered why the sky is blue? Why can't it be pink or green? Why does it have to be blue? Well, a lot of people ask the exact same question, and it took quite a long time to find out, but here's how it works.
So let's start with the sun. The sun gives us light, which is just a kind of energy that radiates and travels in waves, sort of like the waves that you see at the ocean. They're also called electromagnetic waves. These electromagnetic waves also have things that are called wavelengths. A wavelength is the distance between two bumps of a wave. They're also known by this specific sign. Then there's also the frequency. The frequency is the number of wavelengths per second. You should remember that the longer the wavelength, the lower the frequency, the lower the energy of the wave. These electromagnetic waves also travel at a specific speed, exactly at 299.796 kilometers per second. This is also called the speed of light. If you could travel at the speed of light, you could run around the Earth 7.5 times in a second.
My friend Barney here would look directly into the sun, which I do not recommend, and do not do this. He would be seeing white light coming from the sun. Well, white light actually consists of all the colors of the rainbow. You can see here that each electromagnetic wave has its own color, and they all have different levels of energy in wavelengths. Red, for example, has the longest wavelength and therefore the least energy. Blue and violet have the shortest wavelengths and therefore the most energy of all of the colors.
So we know that light can get through space, but to get to our Earth, it needs to pass through the atmosphere. The atmosphere is just a mixture of gas molecules surrounding the Earth, mostly of nitrogen and oxygen, but there's also small particles like dust and other stuff stuck in it. So that's me right there. Imagine the sun is directly above us. It's sending all its electromagnetic waves in all the different colors towards the Earth. When they hit the atmosphere, let's see what happens. So we know there's gas molecules and dust particles in the atmosphere, but all the electromagnetic waves with their different colors react differently to these. The electromagnetic waves with the longer wavelengths like red, orange, and yellow, they go straight through the gas molecules. However, much of the short wavelength light like blue and purple is absorbed by the gas molecules and then scattered all around and rescattered and rescattered. Whichever direction you look, some of the scattered blue light reaches you. Since you see the blue light from everywhere overhead, the sky looks blue. This whole concept of the blue light scattering on the Earth is called Rayleigh Scattering effect. And it was actually found by this guy called John William Strutt. He also named himself Lord Rayleigh. Of course, there's also a formula. The intensity of scattered light is 1/4 power of wavelength. But weren't the purple wavelengths shorter than the blue wavelengths? Shouldn't the sky be purple? Well, it actually should. But our eyes only see the blue because they're more sensitive to blue light than to purple light. Okay, but then what about sunsets? They're always orange or red. They're never blue. We know that blue light is scattered most. Well, at sunset and sunrise, the sun is at the side of the Earth. So the light has to travel a much farther distance through the atmosphere than before. As we know, red, orange, and yellow light, they just go right through the molecules, so they get to us first. But the blue light is scattered all the way but never really gets to us. Just think of blue as the overworker and red as the person who gets right to the point. To show you the Rayleigh scattering concept in a different way, I'm going to do an experiment. So you'll need a glass container with water and milk, which represents the atmosphere. The milk is just part of the dust particles, and a white flashlight, which will represent the sun. Turn the lights off and move the flashlight around your glass container. You'll see that the water in your glass container will slowly turn orange-yellowish as the flashlight is right in front of the camera, and blue, like a light blue when it is on the side. There you go, we've created our own atmosphere at home.